Hello, welcome back again for 205. Today we shall study exact equation section 2.3. So let's start writing our differential equation. We consider the differential equation dy by dx equal to f of x of y. This is what we did in the previous section, but this time we shall put this is equal minus m of xy divided by n of xy. So we shall use another form for the exact equation. So let's multiply dx here and dy with this term, and we write our differential equation m of xy dx plus n of xy dy equal to 0. So this is our standard. Let's put it equation 1. So we shall, in this section, we shall consider the standard form of equation 1 for the first order differential equation. Let's now define what's meant by exact. Okay, so I will use a color, red color, to put this exact condition. So 1 of this section, exact condition. Okay, and we'll return back to what we write with the black. So the differential equation 1 is said to be exact if and only if partial m by partial y equal partial n by partial x. And let's put this condition number 2. So you have your m dx, so you differentiate with respect to y. N is dy with respect to x. So this is the condition for exact. Let's explain what's meant by partial derivative. In calculus, if you have function like f x squared y cubed, then we say that partial f by partial x, you treat y like a constant and you differentiate with respect to x squared, so it will be 2, very simple, 2xy cubed. If you do the other for y, so it will be you treat x as a constant, so it will be like that. 3x squared y squared. You differentiate y cubed and you leave x squared. And this is, we write it really, we simplify this by writing very simple fx, and this is writing fy. So this is the meaning of partial derivative. So in this condition, I will write it with fx and fy. Let's say just clean what I write here. So this is, we don't need it. In fact, just explanation the partial derivative. So this condition means that we can write now the same. If I write m y equal nx, the same. This is the same condition too. So we concentrate in this condition. Let's have another example for that. Example. And I will put it 1, okay? Okay, we shall check now if the differential equation is exact or not. Take this differential equation, x y squared plus y dx plus y x square plus x dy equal to 0. So this is our differential equation, and we need to check is it exact or not. So we need to check the condition number 2. Now you must check this. This is in the standard form of equation 1, and it's very clear. It's in the standard form. The coefficient of dx is called m, so this is m, and this is n. So let's differentiate. So m of y equal 2xy plus 1. Okay. nx, it will be 2yx plus 1. They are equal, so it must be exact. So we write m of y equal nx, means that exact. So we are proving this differential equation as okay. Now we shall give the method for solving exact equation. So let's let's go now for another page, and we start number 2. Okay. Method for solving exact equation. Okay, let's try change the color and put in a black now. Okay, now the solution now the solution for equation 1 in the form f of xy equal to c. Let's put this equation 3. This is implicit form of the solution, and we need to find f. So this is the most important. This is the solution for equation 1. To do that, first, if this is the solution, then take df equal partial f by partial x dx plus partial f by partial y dy equal to 0. Let's put this as 4. Now this equation 4, because f is the solution, is the same as equation 1. So compare equation 1 with equation 4. So you get partial f by partial x equal m of xy, and partial f by partial y equal to nxy. And this is the most important condition. Let's put them 5. Now from 5 we can find the solution either by using the first condition or the second condition. So we have two methods. I will do method 1. Method 1 using condition partial f by partial x equal to m of x and y. Okay, now you want to find f, so you need to integrate with respect to x. So your f, the solution, will be integration of m of xy with respect to x. Okay, in calculus You have one variable, you add a constant c. Here you have two variables, the constant must be a function in the other variable. So I will call it function of y. So this is a function of y because you are integrating with respect to x. Then to find phi of y to complete your solution, you need to differentiate this again with respect to y. Okay, so it will be partial f by partial y equal d by dy of this integral. Okay, I will leave it with very simple form dx. Okay, plus the derivative of this with respect to y, it will be one single variable, so phi prime of y. Now from condition 5, this must be equal. If you go here to 5, this one equal to n. Okay, you have two sides of equation, so you need to solve this equation. Equation for phi prime of y, and then for phi of y. Then this is it. Then the solution is given after that by equation 3. You take this and you substitute back in equation 3 by using, let's say I put a number here for that. No, it's okay. Phi of y here for this. So you need to, after finding phi, to substitute back, then use a 3 to find the solution. Okay, this is method 1, I called it. Method 2, I will leave it as an exercise. You will use the other condition. It will be df by dy. It will be n of xy. I will do in the exercise by two methods. This one you can integrate again. You do the same way as we did in method 1. So I will leave it as exercise.